Eureka! Oh, hello there. I was just doing some analysis on Ford Motor Company's exciting hybrid electric vehicle, the Prodigy. If my calculations are correct, the Prodigy can go from New York to San Francisco for less than... How much? This is unbelievable. Well, I guess there's only one way to find out. Remember, the true answers in life are not always discovered by taking the most obvious route. To demonstrate Prodigy's efficient hybrid design, we'll travel from town to town through traffic across the country on surface streets and back roads to show how Prodigy converts coasting and stopping into useful energy. This is going to be exciting because the Prodigy is an extraordinary hybrid electric vehicle. It's built with highly efficient drivetrain components, like a lightweight 1.2-liter aluminum compression ignition engine, an integral starter alternator, an advanced high-power battery, and an automatically shifted manual transmission. From the driver's perspective, the Prodigy drives just like a conventional car, with some important advantages, like very low emissions, and as you can see, outstanding fuel economy. Remarkable, isn't it? New York to St. Louis for under $15. Pretty cool, eh? That's the kind of efficiency you get with Prodigy's high-tech hybrid design. The lightweight compression ignition engine powers the Prodigy only when you step on the accelerator. When coasting, engine power is not required, and the fuel is shut off. And as you decelerate or apply the brakes, the starter alternator converts Prodigy's forward motion into energy that is stored in the battery. So right now, Prodigy's not using any fuel at all. In fact, it's actually generating energy. That's more than economical. It's phenomenal. Now, as the Prodigy slows to a stop, the engine stops and the fuel remains off. That's how Prodigy goes so far, so efficiently. Wow! Less than $28 from New York to Denver. That's impressive. I spend more than that for a haircut. We saw how Prodigy's fuel shuts off to save energy during deceleration and how the starter alternator generates energy. Now, when it's time to accelerate, stepping on the gas causes the starter alternator to start the engine. And without hesitation, you're on your way, all within a fraction of a second. Actually, 0.2 of a second, like that. But who's counting? So, the same starter alternator used to convert Prodigy's rolling motion into electric energy also starts the engine and provides extra boost when more power is required. Along with its efficient powertrain, Prodigy's lightweight design, which includes an aluminum body that meets all required safety standards, means it takes less energy to get rolling, and Prodigy's highly aerodynamic styling and special tires mean that it takes less energy to keep rolling. Speaking of rolling, we've traveled a long way for very little money, thanks to Ford's innovative approach to building a technically advanced vehicle that's more fuel efficient and more environmentally friendly than vehicles most of us drive today. Ford's next challenge is to make it as affordable as the cars we drive today. The key is to use fuel only when it's needed, and even then use as little as possible. That's the Ford Prodigy, a car so efficient we can travel a distance like New York to San Francisco for under $50, getting over 70 miles per gallon. Now, I'm no Einstein, but relatively speaking, I'd say the Ford Prodigy just might change the way we see the world and help make our planet a cleaner place to live.
There are 7 major fuel economy technologies being used by engineers in developing the Prodigy. They are reduction of mass, smaller engine, instant on-off capabilities, regenerative braking, advanced transmission technology, better aerodynamic design, and reducing rolling resistance of tires. Engineering design number 1. The reduction of mass. The energy needed to propel an object at a given velocity is directly proportional to its mass. Decrease the mass by 40% means a decrease in the amount of kinetic energy by 40%. Prodigy's mass is 40% less than today's midsize vehicle. Less mass means less energy is needed to provide the vehicle with the same velocity. Engineering design number 2, smaller engine. With lower energy requirements because of lower mass and other fuel economy designs, a smaller engine can be used. A 1.2-liter diesel engine is less than half the engine size of today's average midsize car. A smaller engine uses less chemical energy to operate. Engineering design number 3, instant on-off capabilities. There is no reason for having the engine operate while waiting at a traffic light, stuck in traffic, coming to a stop, or coasting down a hill. Sensing these conditions, the Prodigy shuts off its engine. That results in a substantial savings of the chemical energy stored in the fuel tank. With chemical energy stored in the batteries, the engine can be started instantly when needed. Engineering design number 4, regenerative braking. Today's braking systems transform 100% of the vehicle's kinetic energy into thermal energy when the brakes are applied. Prodigy has 2 ways to stop the car. The first is to create friction, which changes the mechanical energy to thermal energy, much like the brake pads on a bicycle that press against the wheel. The second way to stop the car is to make the rotating wheels turn a generator that makes electricity. The electricity can be saved as chemical energy in a battery for later use. Typically, about 10% of the mechanical energy is stored in the battery during this process called regenerative braking. The electrical energy is then stored as chemical energy inside the high-power batteries located in the trunk's wheel well. This stored power may be needed to start the engine many times during a trip. The stored electrochemical energy in the batteries may also be required to produce electrical energy when more power is needed by the driver. Engineering design number 5, advanced transmission technology. Newton's first law of motion tells us that a body at rest will remain at rest unless it is acted upon by an outside force. To overcome matter's desire to stay at rest, the vehicle's transmission allows the car to change from rest to slow, to moderate, to fast. These gear changes are done by having the driver change gears manually or by having it done automatically. Many drivers prefer an automatic transmission over a manual transmission. An automatic is simply more convenient, which, for some, outweighs its lower efficiency. The driver's decision when to shift can affect the amount of energy transferred into unwanted thermal energy. Prodigy has a manual transmission which is shifted by a machine at the most efficient time. This gear-shifting robot reduces thermal energy transfers and increases fuel economy. Engineering design number 6, better aerodynamic design. Of the 15 units of mechanical energy possessed by the wheels of today's midsize car, 11 units are transferred into thermal energy as a result of tire friction with the road and air resistance. Prodigy's better aerodynamic design reduces air resistance and the mechanical transfer of energy into heat. This results in higher fuel economy. Engineering design number 7, reducing rolling resistance of tires. Reducing rolling resistance of tires with the road while maintaining safety is a task for engineers. This reduction is primarily achieved by manufacturing a lighter automobile. Less weight means less force between the tires and the road. Also, there is less flexing of tire materials, which causes the production of thermal energy. Tire pressure, design, and composition can also reduce the transfer of motion into thermal energy. Advanced technology and innovative engineering designs will result in concept cars with almost 3 times the fuel economy of today's midsize passenger vehicle. This will be accomplished by managing the use of chemical and mechanical energy and its transformation into thermal energy. As these technologies are proven to be durable, reliable, and affordable, they will be put into production. Some already have.
Hi, my name is Ruth. I know you've just been learning about Ford's concept car, the Prodigy, and probably still have some questions about it. I will be asking Mr. Powers some of these questions. Thank you, Mr. Powers, for joining us today.
Well, thank you, Ruth. It's a real pleasure to be here.
With lightweight materials, will this car last as long as today's cars?
Definitely. In fact, this vehicle has a lot of aluminum in it, like airplanes do. So airplanes last a long time, corrosion-free. It will last.
Prodigy shuts off the engine when you're stopped. How do you know it will start when you press the gas pedal again?
Well, we have made cars go 150,000 miles durably for years, and we have many test procedures to check this out. We take cars, we put them on test tracks, we put them in fleets. Also, we have modern computer technology to help us do that. We have electronic ignition and electronic fuel injection, as well as fail-safe procedures to make sure it works.
Will starting and stopping cause the engine to wear out sooner? Will we notice the starting and stopping when we're riding in the car?
First of all, it will not affect engine life. Second, we worry about noises on board the vehicle, and so we will make it so it is imperceptible. In fact, you'll just feel like it's a very smooth idle and just almost noise-free. Then when you touch the gas pedal, the car will start right up and you won't know the difference.
If the Prodigy uses diesel fuel, does the environment still benefit?
Yes, because there's two kinds of pollution we worry about. One is called smog, and that's very local, like you see in cities. We also worry about greenhouse gases, and these are across the whole globe. And diesel helps us deal with the greenhouse gas problem. So it will reduce emissions not only locally, but globally as well.
When will people be able to buy the Prodigy?
Ruth, this is an experimental vehicle. It has hundreds, even thousands of new parts on it, in the engines, transmissions, the body, new materials. So some of these we've already qualified, and they're coming into cars today. The whole vehicle, with all of these concepts, be on the order of 5 to 10 years from now.
Thank you, Mr. Powers, for joining us today. I hope I'll be able to drive a Prodigy in the near future.
Well, thank you, Ruth. It's been a real pleasure to be with you.